Hello, class. We are very sleepy. Please enjoy my mom's video and be good for the sub. Good night. Hi, guys. It's very late. Charlie and I want to go to sleep, but that's alright. Here are your notes for Friday, October 2nd. So Powers of Powers is the title. If you want to pause and add this to your table of contents, that would be great. So today what we're going to talk about is what to do when we have exponents in our base, and then we also have exponents outside of the base. So we have an exponent to another exponent, okay? That's what I mean by powers of powers. So remember how we talked about the importance of expanding? And that's really going to be true here. This is one of those times where we make silly little mistakes that can be easily prevented if we just weren't lazy and we took the time to expand. Okay? So let's look at the first example. It says a to the fourth power. That's our base. And the exponent is 3. Okay? So what this is telling me is that I need to multiply my base, a to the fourth power, by itself 3 times. Okay, so here's what we're going to do. We're going to expand our base, a to the fourth times a to the fourth times a to the fourth. Okay, because I needed a to the fourth 3 times. I'm going to zoom in a little bit more here. It's kind of looking weird. Alright, so now I know what to do if I'm multiplying and I have the same base. But I'd rather be safe than sorry. So I'm going to continue expanding. A to the fourth would be a times a times a times a. Another one. So here's the first one. We're going to now bring down this one. A times a times a times a. And our last one. A times a times a times a. So now all I need to do is figure out how many a's I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my final simplified answer is a to the 12th power. Maybe you can start already seeing if you have any predictions about a rule here. Okay, noticing a to the 4th, all to the 3rd, and this was our final answer, a to the 12th. Alright, the next example that I would like you to write down, sorry, I'm moving this around a lot, but it doesn't look right on my computer. Alright, so our next example says, my base is m squared to the 6th power. So I need to write my base 6 times. 1, 2, 3, 4, 5, 6. Again, the other day we talked about multiplying factors, right? When the base is the same, all I need to do is add my exponents. But rather be safe than sorry, let's just make sure if we expand, we can see what happens. It's a lot of M&Ms. Okay, so 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 M's. M to the 12th power. Whoops, sorry, you can't see that. There we go. So again, we had m squared all to the 6th power, and we ended up with m to the 12th power. Let's try the next one. Let's not only simplify it, let's actually then evaluate it and see if we can figure anything else out. So my base is 3 squared, and I need to do all of that to the 2nd power. So I need to write my base 2 times. 3 squared times 3 squared. All right, let's keep on expanding. 3 squared really means 3 times 3. 3 times 3. So that means I really have 3 to the 4th power, right? 1, 2, 3, 4. My base is 3. I have 4 of them, 3 to the 4th power. Now, if I were to actually evaluate this expression, I would have 3 squared, all of that squared. So I would take, I would expand my base, 3 squared, and I need it 2 times. And I know 3 squared is 9, so 9 times 9 is 81. 3 to the 4th power, 3 times 3 times 3 times 3. If I were to evaluate that, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I'm getting the same thing, except here you can see it when I actually solve it, compared to here when I'm just simplifying my original expression to a simpler form. Okay, so it just depends on what the instructions ask you to do, whether it's simplify or whether it's evaluate. Now this next one is a little different because we can see our base has a few terms here. We've got the 3, we've got z to the 4th, and we have n. Okay, so the first thing I do is I expand. I take my base and I multiply it by itself however many times my exponent wants, in this case 4. So we have 3 z to the 4th times n times 3 z to the 4th times n times 3z to the 4th times n times 3z to the 4th times n. Remember, because my base 4 times, 1, 2, 3, 4. Now I need to expand, I need to continue expanding, okay? Whew, this one's going to be a lot. Okay. 3 times z, 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 n times 3 times z, 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 n, up. Z, 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 n times 3 times z, 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 n. Okay, I'm running out of room. Sorry about that, guys. Can you see that? There we go. Okay, so now I need to, combine as much as I can. 3 times 3 is 9, times 3 is 27, times 3 is 81. So all of my actual numbers I can combine to 81. I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 z's, so z to the 16th, and 1, 2, 3, 4 n, so n to the 4th. And this would be the simplified version of this if I do my powers to powers. Okay, so if you're feeling kind of confused, again, look at what I did first. I rewrote my base 4 times because that's what my exponent told me to do. And then I expanded all of that to help me to figure out how many of each of these terms I had. And that's the final answer. The last one says, in parentheses, 5gw cubed. So this whole thing in parentheses is my base. My exponent 3 is attached to the entire thing because it's all in parentheses. Okay, so the first thing I'm going to do, let me move this down a little. I'm going to write my base however many times that exponent tells me to. So I need to write my base 3 times. So here we go. 5gw cubed times 5gw cubed times 5gw cubed. Now I'm going to continue expanding. 5 times g times w, w, w. 5 g, w, w, w. 5 g, Okay, now that I've expanded, I go through it and I see what I can simplify, what I can put together. 5 times 5 is 25, times 5 is 125. G times G times G is G cubed, or G to the 3rd power. And it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 W's. W to the 9th power. So what I would like you to do now is take a look at these 5 examples. Okay, you've just completed 5 examples with me. Is there anything that you notice about what happens when we multiply a power to another power? So taking a look at our original problem, our original expression, and then looking at the final simplified answer. Is there any connection that you can make? Hopefully you are seeing a connection, an observation here. So I want you to try and brainstorm the rule. Okay, so your job is to come up with a rule for when we multiply powers of powers. And then we'll see what you guys came up with on Monday. When you do your IXL skill for this, hopefully now you'll feel a little bit more confident. But remember that if you get it wrong, you really, really, really should read the explanation. It will tell you what you did incorrectly, and it'll help show you how to do it properly, okay? So now that you've checked your homework, and now that you've taken your notes for today, the next thing you're going to do is you can work on any of your IXL, okay? The next